All right, we are recording. We are recording. All right, have a seat, please. Can you close that door on your way back?
I know. I gave him a pencil. I don't know why I did throw him down.
That word. That word.
It didn't.
All right.
Can we get the fan blowing in here?
Yeah. Fan blowing?
Yeah.
I don't know if it'll help, but I can do it.
Oh, it will.
All right. No, I got twisted. And.
Boom.
All right. We're going to do properties of exponents and radicals. All right. So we are delving even further into the whole thingamabob. Oh, that's not what I want. It's lesson 4. So we're going to jump. We're going to jump even deeper into how exponents work. Here's what I want you to do. Does anybody not have this packet? All right, I'm assuming everybody has a packet then. On the top right-hand side, about right here, I need a table. We're going to do 3 columns, just like that. And we are going to do 0 through 7. That's right, it is. 5, 6, and 7. 0 through 7. Okay? So we're going to start with this. Okay? This is going to be a little, what we'd call a support, so that when we don't have to try and remember what 7 cubed is off the top of our head. We're just going to build a table right now that we can refer to throughout the lesson. Is that fair enough? Sounds good. Good hat game, by the way. I like the hat game. So, 0. If x is 0, then what is x squared? 0. And x cubed is also 0. That's pretty darn easy, don't you think, Jasmine? What about if x is 1? What's x squared? 1 and 1.
4.
2. X squared is 4. X
8.
cubed is
8.
3. 9 and
8.
27.
Yeah.
3 times 3 is 9. Times 3 is 27. 4. X is 4. 4 squared is 16. And 64. Good, Lars. 5 squared.
25.
25. Oh, I made my...
125.
Nice.
Heckin' right.
What?
Heckin' right.
Okay. I was looking at the microphone for anybody that can't see me. That's what I was doing. 6 squared. 36. 6 cubed. 216. You've been punching these into the calculator? These are just up here, aren't they? 216, you say? Or is it 218?
49.
No, it's 16. You're right, 16, yep. Okay. 7 squared. 49. 343. 343. 9 times 7 is 3, so it'd be 6. All right. So, we're going to use this as a support to help us throughout the lesson. Okay?
Flying.
However, comma, let's start by doing the opening exercise. All right, we're going to rewrite each exponential expression as a radical expression. And then we're going to use the definition properties of radicals to write the resulting expression as an integer. Now, if I presented you with this problem, what would be your strategy in order to come to a solution? What would you do? Add the exponents, right? Got the same base, I can add the exponents. But it asks us to rewrite each expression as a radical expression. So we are going to do what we are told. That's an expression with our brackety things. And our 7 to the 1/2 power is the same thing as square root of 7. That's what we covered.
Put a 2.
You don't have to put the 2 because in this one the 2 is understood. Now if it was the cubed root, like this one.
Oh, I understand.
Yeah?
Yeah.
Okay. Does everybody understand Bailey's question? He's saying, why not put a 2 here? And I could, but do I have to? No, because I know when I write just that, that means square root. We clear on that, Olivia? All right.
How do you get square root of 7?
Well,
You just put the
this is the square root of 7, right? I'm not done with this yet. I'm also timesing it by this, right? Which is also the square root of 7. And now I can rewrite this as, I'm going to get rid of this arrow that I put right here.
I should write regular 7. Just be.
Because it says, write each exponential expression as a radical expression. You want to jump to letter E, but I'm taking this from A to B to C to D and then to E. We're going to get to E. Now, here's what I do, Jesse. The root 7 times root 7, it's root 7 squared. Or I could say root 49, right?
Which equals.
Right, right. Or the square root and the square cancel out.
So
Either way, and this equals 7. And now I'm going to put my fancy box around it. Okay? Did you see how I worked through that line of reasoning? Now let's do the same thing for 3. What's the radical expression that's the same as 3 to the 1/3 power?
3. Square root of 3.
Is that the square root of 3?
Wait, I got a question.
Hold on, before your question. Is this the square root of 3? What is it, Jeff? Cubed root of 3, right?
I was getting it.
Good. And that's when I put the little number up here. So it's the cubed root of 3 times the cubed root of 3 times the cubed root of 3.
Well, why is it?
Oh. You're asking that, aren't you? Yeah. Good catch. All right. What's your question now, Andrew?
What do you do with exponents like the 1/2 and the 1/3?
7 to the 1/2 is the same as the square root of 7. That's what we talked about the other day, right? That's what we talked about. What's that?
But he didn't explain it, he just wrote it.
So, 3 to the 1/3 power is the cubed root of 3. Andrew, those mean the same thing. 3 to the 1/3 and the cubed root of 3. They mean the same thing. Okay? Now, Remember how I did it this way before? I'm going to do it the other way now. I'm going to take the cube root of 3 times cube root of 3 times cube root of 3, which is the cube root of 27.
You put a 9 there.
What's that?
Well, it's
Nope.
9.
Because remember, this times this is the same as this to that. I'm using that property. And the cube root of 27, well, I go to 27, right,
9.
in the cube column, and I go over to the x column. And it's 3. And now you've seen how the table helps us, right? Now, one over 12 squared, or no, not 1 over 12 squared, 12 to the 1/2, and 3 to the 1/2. Yeah, I can't do it because I need a common base, right? But can I do this? 12 to the 1/2 is the same as saying, can I say 12 to the 1/2 is that? I can do that, right, Jeff? And then I can't forget the 3 to the 1/2. So this becomes that. This comes over here. Now, I'm using this property. I'm using this property. So 3 times 4, all to the 1/2. That's the 3. That's the 4. That's the 1/2.
Why would
That equals 3 to the 1/2 times 4 to the 1/2. Do we see how that rule helps us?
How is it? Why is it 1/2 instead of 2 like last time?
What do you mean?
Up here when it was 1/2, it was 2. Like this number. This with the 2 right here.
Yeah, I haven't converted it to a radical yet, have I?
Oh,
I haven't converted it to a radical yet. So, I'm going to rewrite this now over here as 3 to the 1/2 times 4 to the 1/2. And then I got 3 to the 1/2 still. Multiplication. Is it commutative? Is multiplication commutative?
yes.
What does that mean, Olivia?
Alright.
3 times 5 is the same as what? 5 times 3. So I'm going to order this around a little bit. I'm going to erase some spots here. I'm going to put these two guys together. So it's 3 to the 1/2 times 3 to the 1/2 times 4 to the 1/2. So far, so good, right, Jesse? Now I'm going to change them to radicals. Square root of 3 times square root of 3 times square root of 4. I'm taking a long way to get to answers, aren't I? Yeah. Yeah. This times this is what?
4 is 2.
That's 3.
Equals 3.
And what's that?
2.
2. 3 times 2 equals 6. Bam.
Wow.
Wow, that's right.
Impressive.
All right. Oh, good. Now I get some room. 64, I'm going to rewrite this to the 1/3 power, all to the 1/2 power. So remember, this equals the square root. This is going right here. And then the square root of the cube root of 64. Right? So, here's what I want to do. I want to start on the inside and work my way out. So I got to figure out what the cube root of 64 is. So let's find 64 in the cubed column.
4.
So 64 in the cubed column is right here. And I work my way back over to the x column, and I got 4. So 4 is the cubed root of 64. So this equals, this guy equals 4, right? So then I got the square root of 4. And what is the square root of 4, ladies and gentlemen? Do we need to convert or to refer to our table for this one?
2.
That's just 2.
That's
Equals 2.
That's the answer.
That's the answer. Okay? Wow. Wow. All right. Next page. Next page. It says, write each expression in the form of b to the m over n power for positive real numbers b. Positive real numbers b.
So would it be 4 squared?
Hold on. And integers m and m with n greater than 0. By applying the properties of radicals and definition of the nth root.
Words make it complicated.
They do, and they do their best to make these words complicated because they want you to be able to translate math speak. Okay?
I hate them.
All right, so first of all, let's convert these to radicals. B to the 1/4 power is the same as what root of B? B to the 1/4 power is the same as the what root of B?
Square of b.
The
4.
4th root. So this equals the, that one equals the 4th root of B. That one equals the 4th root of B. So 4th root of B times the 4th root of B. Okay? Now, that's the same thing as the 4th root of b squared, right? You can multiply stuff inside, right, Ethan? Now, think about this. How would I put this? What times itself 4 times gets me b squared? What times itself 4 times? So let's use numbers instead of b. Let's use the number 2. Let's say b is 2. What number times itself 4 times gives me 2 squared? What is 2 squared?
4.
4, right? So I got to think back. What times itself twice gets me 2 squared? Well, 2, right? 2 times 2 is 4. But now I got to do one. I got to do another time, right? I got to go. What times itself again gets me to 2. I'm not doing a good job of explaining this at all, am I?
And the cubed root of it.
Not the cubed root.
So like the 3rd power.
I got to find something that I'm finding the number. I'm calling the question mark. That when I take it to the 4th power, I get b squared. That's what I'm trying to do, right? Now let me ask you this.
Would it be a?
Let me ask you this. Here's a good one. Here's a good way to think about this. The 4th root. It's like taking a square root of a square root, right?
Yeah.
Would you buy that?
Yeah.
If I take, let's think of a number that times itself 4 times. 2 times 2 times 2 times 2. That would be 2, 4, 8, 16, right? 16 is 2 to the 4th power. Take the square root of 16, and you get 4, right? Take the square root again, and you get 2. That reasoning makes sense to us. If I take the square root twice, it's like taking the 4th root. So, here's what I'm going to do. I'm going to say this thing is equal to the square root of b squared.
We have 2 square roots.
I just spent the last 5 minutes explaining that.
I don't get it. The square root.
Absolutely no sense.
Yeah. Can't concentrate on being an asshole.
So, think about 16, right?
Square of square root.
So you get it, you just don't like it.
Except that.
The thing is sometimes stuff's going to be presented like this to you. Now, again, start inside and work out. What's the square root of b squared? So I'm looking at this guy right now, right? So that's b. The thing I circled is b. But I still got the square root bracket outside of it, right? So this thing equals the square root of b. And that's my answer. Do we see the reasoning there?
Yes. Go back up.
Yeah. That would be great, except it wants me to apply the properties of radicals, doesn't it? I can. Like I said, they wanted me to use radicals. So Lars had a good question. I got b to the 1/4 times b to the 1/4, right? If I got the same base, what can I do here? How do I combine them? By doing what to the exponents? By adding them up, right? And 1/4 plus 1/4 is what? 1/2, which b to the 1/2 power is square root of b, right? So why don't I just do that? We could have, but the question said do it in applying the properties of radicals, right? So what's the point of this lesson, Jasmine? What did you say this was? My way? What did you say my way was? Go ahead and say it. It started with an S and ended with 2, but right. Right. So this was a stupid way of doing it. But this was the easy way, right? This is the easy way. But in order to do it the easy way, what do we need to know? We need all this business, right? This business, the rules for exponents. Because what you had before can model kids jumping up and down, but it can't model sending spacecraft into the moon, right? It's beyond you right now, Jasmine. It's not beyond you forever. All right. Should we apply rules of radicals or the rules for exponents in doing this for one? Should we use rules of radicals or rules of exponents? Radicals then. So the cubed root of b times, what's b to the 4/3 power? Oh, it is the cubed root of b to the 4th power. So now I got the cubed root of b times cubed root of b to the 4th power is really the cube root of b all to the fifth power, right? Now, how many of those cube roots give me a b?
Because that.
This times this, I got this, right? Which is one of them. Times this, which is four of them times to itself, right? So 1 times 4 more gets me 5 of them. Now, I got 5 of these things multiplied to themselves, right? How many of them get me a b? How many cube roots do I have to multiply by themselves to get me a single b? Cube root. 3, right? The cube root of b times the cube root of b times the cube root of b gets me b. How many do I got left over? I got 2, right? So this equals b times cube root of b squared. Or I can just write b to the what power? 4/3 plus 1/3 is 5/3, right? Yeah.
Wait, what now? Say that again. So wait, what else can I? How else can I write it?
Add exponents, right? You got the same base. Your base is b over
So
here.
the answer could be 5.
B to the 5/3.
So
1/3 plus 4/3 is 5/3, right? So this really is a lesson in salesmanship. This is showing you the really hard and mentally taxing way to multiply these things together. And then saying, hey, look, there's this way that's so much easier that we're working on right now. Would you like to learn?
easier, yeah.
Easier, yeah. All right. Let's do this one using exponents. Let's do this one using the rules of exponents. I got common bases, right? B to the 1/5 plus or times b to the 3/4. They're both the same base, right? The base is the b.
Oh yeah.
I got the same base.
Yeah.
So I can do what? I can add the exponents. Now, what's challenging about this one?
They don't have the same denominator.
Right. So we get to do Friday Fun with Fractions Friday. So it's not, but you know what? So it's Friday Fun with Fractions Friday on a Thursday. So this is b to the 1/5
Why did it get so low?
plus 3/4 power. Now what do we got to do? You gotta add fractions, right, Jordan?
What?
I gotta add fractions now, right?
What you say?
How do I add fractions? How do I add fractions? All right. Let's take a break. Everybody talk amongst themselves for 2 minutes. 2 minutes, go. Abby's not going to talk to anybody then, I guess. Talk about amongst yourselves on how to do this.
Cross multiply. No, if you pop it. Really? Come back. Wow.
Okay. Who's able to add 1/5 to 3/4 to come up with a rational number? I know one person was able to.
Oh wait, hey. Is this where you multiply?
It's where I find the common denominator.
I know, that's where you multiply the denominator by something that both go into each other. Ah, yeah.
What's my common denominator going to be? 20, right. So what do I multiply 5 by to get 20? So I multiply the bottom by 4, I multiply the top by 4 too, right? So this is b to the 4/20th power plus, bam. Now, do I have common denominators, Jesse?
Yes, you do.
B equals 19 over 20. So this is b to the 19 over 20. Now, that wasn't very easy, was it?
That was easy, yeah, that was really easy.
Was that really easy?
Yeah.
It's easier than doing the radical thing, wasn't it? Imagine doing this radical thing on this one. The radical thing. Doing it that way. Would that have been some hot garbage there? Hot garbage. Do we want to do that? Sydney, do you want to do this one this way?
No.
Or do you want to do the new coolness way? Do you want to do old and busted or the new coolness?
New coolness.
New coolness. We're doing it with the new coolness. All right. We're doing everything with rules of exponents now. I want everybody to try and do number 1, exercise 1, together. Or, well, amongst yourselves, I'm sorry. Everybody do number 1, b to the 2/3 power times b to the 1/2 power. B to the 2/3 times b to the 1/2. Some of you are just cutting to the chase and going right into adding fractions.
I got it. Check me.
What? Oh, oops.
I did something wrong. Hold on now. Hold on now.
That's what we should be at. Those are the fractions we should be adding, right? You down with that? Yes, Jasmine. Yes. Oh, you want me to see if you did it right?
I got it. That is the answer.
So you're doing. So when you're multiplying two things on the same base, with exponents,
What?
we're trying to I can't say 1 and 6.
No, that's why I need to start
Four, 6. This is 6. Oh my God.
Now that has to be. Yeah, I heard. I wasn't even I'm telling you the truth.
After converting fractions to common denominators, I get this, right?
Yes.
And that equals b to the 7/6 power. Feel me? How about this one? When I got a power to a power, When I got power to a power, what do I do? Power to a power. I do what to the exponents? Multiply the exponents. So this is b to the negative 1/5 times 2/3 power. And now I do that math. How do we multiply fractions, ladies and gentlemen? That's division. That's division.
Cross simplify.
Can I cross simplify anything?
Nope.
Nope. So then I can go right to doing what?
Adding, multiplying across.
Multiplying across, right? The 1 times the 2 gets me a new numerator. Actually, negative 1 times the 2, so that's negative 2.
15.
How do you multiply fractions? No, that's division. That's division. Division is multiplying by the reciprocal. Multiplying is just multiplying. You go numerator times numerator gets me new numerator. Denominator times denominator gets me new denominator. And then I get my answer. I'm sorry? You tell me. It doesn't matter. It's the same thing, right?
Spencer's junior year highlight reel. 6 minutes. Not watching. Actually, don't worry.
We're almost done. Almost done. Okay. Number 3, exercise 3. Again, same base, right?
Yes.
Same base. So what can I do with the exponents? If I have the same base, I'm multiplying 2 same bases. What can I do with the exponents? I add the exponents. 64 to the 1/3 plus 3/2 power. Then I gotta make those the same denominator,
I
right?
got a question for all these.
Uh-huh.
Like that. What happens to the other 64? You only write one down.
I'm using this rule. When I have 2 things with the same base, right? When I multiply them together, I can write them as one thing so long as I add the exponents. So I got 2 things with the base of 64, and that equals 64 and to the power that's those 2 exponents added together. Anybody get that? You got that? You got that? Bam. I'm supposed to get through this whole next page. I'm supposed to get through this whole next page and halfway down the page after that. That's not going to happen. That's not going to happen. So I'm going to end right now. I'm going to end right now. And I'm going to tell you what's going to be due on Monday. Here's what's going to be due on Monday. Problem set. Number 1, letters A through C, Problem 2, letters A through D and F.
Come on.
Problem set due on Monday. Yes.
Cook.
1 second. Yes, Andrew.
How many hours left is due?
Sure.
I just.
Go ahead.
Me too. I just forgot. And can I have my key back?
Give me my pencil.
There you are. Thank you. Right.
So you're doing this minus that, right? You gotta make them. You gotta make them both the 10 to the 13th, though, right? You gotta make them apples. If this is an apple, you need to make this an apple, right? If this is an orange, you gotta make that one. Either way, they both got to be. Well, you did it. Hold on. So you got 1.42 times 10 to the 14th minus 2 times 10 to the 13th. Oh, 15th here? I'm sorry. Okay, so I either want to make this a 10 to the 13th, or I want to make this a 10 to the 15th. Let's make this 10 to the 13th. Right now, I got to move this 15 places over to show the exact number, right? But to make it, I can go 2 places, and then how many further does it have to go? 13, right? So I'm going to call this 142 times 10 to the 13. It's the same number as this. I'm just expressing it in a different form, right? Minus 2 times 10 to the 13. Now I got apples and apples, right? Now I can just subtract, I can ignore these and just subtract these. 142 minus 2 is what? 140 times 10 to the 13th, right? Not quite done yet, though, because I need to move it back this way. So it's boom, boom, 2 more. It's going to be 1.4 times 10 to the what? 15. And there's your answer. See how that got done? Right? This is multiplication, so I'm doing something inherently different here than I am up here. Okay? Here, I am just going to rearrange my terms. Because multiplication is commutative, right? Order doesn't matter. So I got this, times this, times this, times this. I'm going to put the 1.42 and the 2.4 next to each other. Right? And I'm going to put the 10 to the 15th and the 10 to the 13th together. And then I'm going to do these 2 like that and these 2 like that. So 1.4 times 1.42 times 2.4 is going to come down here, and then times 10 to the whatever is going to be those 2 things. Yep, is 28. Now you just got to crack that out, and then that's your answer, unless that number is bigger than 10 or less than 10. Or I'm sorry, less than 1, in which case you have to mess with the decimal point, right? Got that? Right. Yes, sir. The first exam? And when you mean retake, you mean take it. Right? At least the second part, right? What part did I get? I thought you completed the first part. I thought you worked for Wade and you didn't work for me, which kind of hurt my feelings a little bit, to be honest. I was feeling butthurt at that point. That's all right. We all make mistakes, right? Yeah. Well, give me a second. When are you able to?
Sometime tomorrow, because I was talking to Mr. Cass too about it. 'Cause
Let me know.
Originally, I was going to take it over spring, or before spring break when you were gone.
Yeah.
So,
Yeah, hit me up. Hit me up whenever. If you want to do it with Cass, you can do that too. I work closely with Cass, so that's all cool. Yeah. So, check this out. Yep. I do 1/2 times 2/3, right? Actually, no. Let's do 1/2 times 5/3. How do I do that multiplication? No, that's addition. Multiplication, I just multiply across and then multiply across, right? 1 times 5 goes on the top, and 2 times 3 goes on the bottom, right? That looks like what I got here. I got something times something on the top, something times something on the bottom, right? So I'm going to split this into 2 different fractions like that. So it's going to equal 1.42 divided by 2, and then times 10 to the negative 5th over 10 to the 13th. Right? Now, this is easy, right? Who disrespects me? Who disrespected me today? Oh. You want to sit somewhere else? Okay.
and how would this be?
Well, let's go.